We can do mix if
Okay,
you would
sure.
like. This
Sure,
is
it's up to you.
This is what he gave us.
Okay, write out the vertex form of a quadratic where the original points of the shape of the quadratic describe how each of the parameters change the original quadratic function. Okay, sounds good. Okay, so do you know how to answer that question, or would you like me to go over it in an overview?
Could you please go over it?
Sure, no worries. Okay, so first things first, vertex form, out of curiosity, has your teacher introduced the middle letter yet? Like this form, y is equal to a, open bracket, b, open bracket, x minus c. No? This letter hasn't appeared yet.
No.
Okay, got it. So let's start with what vertex form looks like. So y is equal to a, open bracket,
X
minus, does your teacher use P and H or C and D?
P and Q.
P and Q, gotcha. P, open bracket, squared, plus H. Okay, so this one is called the vertex form. Each letter will change the shape of the original y is equal to x squared graph. Do you have any questions, or are you okay?
Okay.
Okay, so first things first, A has two different functions. It can change the shape. So it will make a shape taller or shorter by changing the y value / distance, y distance between each point and the vertex. It can also, if A is bigger than 1, it will make the shape taller or skinnier. Any questions, or are you okay so far?
I'm okay so far.
Okay. If A is smaller than 1, it will make the shape shorter or wider. Any questions, or are you okay?
I'm okay.
Okay. So, and the last point is if A is negative, then it changes the direction of the shape from opening up with a minimum vertex to opening down with a maximum vertex. Do you have any questions, or are you okay so far?
I'm okay so far.
So let me give you an example of what that would look like. So, okay, let's say you have this graph. The black will be y is equal to x squared. This one is y is equal to x squared. So this one is the original graph. And let's take a look at how each a value changes it. So when a is going to be bigger than 1, so let's say I have y is equal to 2x squared. So it will look skinnier, but in actuality, it's just taller. Please excuse my poor drawing skills, but you get the idea. It'll look like that. When a is smaller than 1, so let's say you have y is equal to 1 over 2 x squared. Then it would look something like this. Again, compare it to the black line. It would be shorter with smaller y values. Any questions?
No.
All right. And the last one is when y is equal to negative x squared. So this one is called a reflection over the x-axis. So it would look something like this. It would have more or less the same shape, but facing in the other direction. Do you have any questions or are you okay?
Okay.
So basically this is what it would look like. So x, y times a. So these are the original points. So let x be the points of the original graph. Where you have x, y times a. So 0, 0, 1, 1, 2, 4, 3, 9, 4. Any questions or are you okay? So all of these will be multiplied by the a value to figure out what it is, okay? Did I lose you at any point or are you okay?
I'm okay.
All right, sounds good. All right, the next part is your P and H. Okay, so P is a bit of an interesting case because you need to be a little bit more careful with it. So X minus P means that you have a positive P. And X plus P means that you have a negative P. So make sure you take the opposite sign no matter what. Okay. All righty. And your P is responsible for moving the graph of y is equal to x squared to the left or to the right. It moves to the left if it's negative, and it moves to the right if it's positive. Questions or are you okay?
Okay.
Okay. Next is your Q. Q is a lot more straightforward. Q moves the graph up or down. Up if positive, down if negative. Questions or are you okay?
Okay.
All right. So if I were to put everything into practice, so transform, let me say, for example, use the knowledge you have about the properties of, to transform the coordinates of y is equal to x squared into y is equal to 2x minus 1 squared plus 3. Okay, so here's what happens, okay? where X and Y are the points of the original graph. So it's going to be X plus your p-value. And A times Y plus your H value. Or sorry, your teacher uses Q, doesn't it? Don't
Yeah.
they? Sorry, that's my bad. Oof.
It's okay.
Okay. So this is what happens, okay? So remember the original coordinates. It'd be -3 and Y would be +9, -2 and +4, -1 and +1, 0 and 0, 1 and 1, 2 and 4, 3 and 9. So these are the original coordinates of y is equal to x squared. Okay.
Okay.
So to find the new coordinates, you would basically have to add p to each one, to each x value. So +1, then +1, then +1, then +1. Then continue on +1, then +1, then +1, and there we go. Then for here, I would go A, so 2 times 9. +3. Then 2 times 4 +3. Then 2 times 1 +3. Then 2 times 0 +3. You get the idea?
Yes.
Okay. So I would basically repeat that up until I finish. And these would be the new coordinates of your graph. Okay. So then the coordinates of y is equal to 2 open bracket x minus 1 all squared plus 3 would be -3 plus 1 is -2, comma, 18 plus 3 is 21. Then -2, so that'd be -1, comma, 8 plus 3 is 11. 0, comma, so 5 actually. 2 times 1 is 1. 2. 2 plus 3 is 5. Yeah. Questions or are you okay?
I'm okay.
Then 1, comma,
Right.
yeah. Then
2.
Yeah.
And 5.
So 2, comma 5. Then
3. 11.
Yep.
And 4. 21.
Bingo. Do you have any questions or are you okay?
I'm okay.
All right. Would you like to screenshot or would you like to just leave it alone? Or you can just watch this again in the recording if you'd like.
Yeah, I could do that.
Okay, sure. Let me stop share then.